Hello, how are you? Okay. As we discussed with Alvaro in the previous email, the main objective of this video is to have to use imaging to calculate the air void properties of asphalt coarse mixture. Okay, so we will start. First, you need to have imaging software. As you can see, here I download VG, which is similar to imaging software. So I will use this software to analysis the samples that you send me. You send me an X-ray CT scans. So first, we need to go to the, if you see the screen, I am sharing my screen now. So eventually, if we go to the file you sent me, I think this is the file you sent me. First step is try to, let's check, just a second, okay, this one, okay. So eventually we have the file, it's fine. There's a file you sent me, the pictures. So I will first make an extract the file. Okay. So eventually we have all the picture now. First step, I will put all the images in one file. So we create a new file. Let's call it the sample test. Okay. And Control A, I will put everything inside this file. Cancel, sorry. Okay. Control A. So this is that's a copy. Sample test, yeah. So eventually you will have a folder, you have all your X-ray and the scans you have. So eventually, before we start, I need or you need to have to know the calibration when you make this CT scans, the X-ray. So when you make the CT scans from the operator or the guy who do the X-ray for you, he will give you the scale or the resolution of the images. Eventually, in XYZ, how many pixel equivalent to millimeter or centimeter for X, Y, and Z. So eventually, you give me the file, the picture. You don't give me X, Y, and Z. You don't give me X, Y, and Z. So eventually, I assume that you have it from the operator who do the scans, the X, Y, and Z. Because it's very important to put the scale in imaging to give a right measurement, because we measure a lot of the air void measurement. For example, if the air void diameter, it will be in millimeter. So eventually the images need to be with the scale. So eventually you need to have XYZ from operator to start working. That's first thing you need to do. If you don't have XYZ, the scale, like every pixel equal how much in millimeter, or each millimeter how many pixels in X and Y and Z. Eventually, in this scan, always X and Y will be similar. Maybe we have a change on different in Z. So I make a quick assumption for X, Y, and Z according to the sample size, because we already know the sample size. As I remember from my PhD that the sample size is a core with 10 centimeter diameter and 5 centimeter in height. So eventually, because I know the real dimension, so I can estimate the X, Y, and Z. Okay. First, you need to clean the images. So we will start now how we use the image program to find the air void properties. Okay. First, we need to clean the images. You will find like some of these images, like example, first images that there is at the top of the core that is not very clear. For example, if we open this one, you will find that that's not very clear. So eventually, if I use this image for analysis, it gives me a wrong answers. So eventually, I try to delete. So eventually, I will delete these ones because it's missed and not correct. So eventually, I will open this one, the first one now, and still have missing. So eventually, if I delete this row again, so eventually I can now, yeah, that's fine. We can start from this one. Okay. So eventually, if we delete another two to be extra sure. So eventually this one we extra sure now. We don't delete this one. Okay, delete and delete one. So eventually we'll start now from image number 40 to image number 199. So eventually in total we delete around 40 images because each sample will be different for sure, but I need to be sure that all the image is clear and we can see all the details very clear. For example, this is very clear, so eventually we can start to analysis now. Okay, first things to do is after we clean the images and prepare it in one file, we open Image or VG or any program you have. I prefer you have Image. Okay, first we need to import the images. How to import the images? Very easy. We make a file and we go import and we go image sequence. So eventually we need to import all the images at once. So how we do that? We have file import and image sequence. He will ask me, please go to the file where you have your images. We know that we have the images here and we call sample list. So eventually, I need just to choose anyone. Let's choose the first one and click open. It will give me this options window. He automatically know that the number of images is 160 with this right, and each like the number of pixels, it's 1,825 pixels by 1,825 pixels. That's XY number of pixels multiplied by 160 the number of slices Z in Z. So eventually, I found during my PhD and my work, especially when I using imaging, that if I import the samples with the right scale, with 100% scale, which is the full size, the file size will be very big, and you will need to have a big amount of memory in your computer system to try to analyze the data. So because we have limited resources using or if you use very powerful computer, you can start with 100. But I found even when I use a very good computer, when I was in Nottingham, even 100, the computer was struggling to do that. So eventually, a clever way to try to rescale everything by 50%, by half. So eventually, how I need to rescale the image by half. How we do that? We delete 100 and put 50%. So eventually, we'll find that the number of pixels is reduced, like very big, reduced from 1,800 to 900. Okay, so eventually here we can find the file size. Eventually, if you have 100, we are dealing with 1 mega, 1,000 mega, which is 1 giga of data, which is a very big data. Like we were working with the data with 1 giga, but if I choose just 50%, So eventually I work into that quarter of the volume with the size, which is very good to like divide it by 4 eventually. So eventually I found it that when we rescale 50%, we will reduce the file size, which is very good for our computational resources. So eventually we click OK, and he will start now import the files, the images. We need to be very careful about that. When we resize to 50%, the scale in XY, it need to be resized by half. For example, if we know that this try here. If we know that the operator gives us that X, Y, Z, for example, he give me this. Let's try it here to be more clear. If we give us X, Y, Z, for example, give us that the resolution every pixel is about, for example, 0.1 millimeter multiplied by 1 millimeter, for example, 0.2 millimeter. So eventually, the size when we make a resample by 50%, so the scale will change on X and Y only. Z will remain constant. So eventually, the number that we take from the operator, that's the size between the slice when he make the adjustment in the machine to make the CT scan. He put how is the distance between each slice when he make the scans. The distance between scans with the number of images we have. So eventually, this number will be constant. This number, when this is, for example, he give me from operator that's the XY 0.1 millimeter each pixel. Each pixel equal 0.1 millimeter. So eventually, when I do 50%, when I do 50% rescale, this one need to be changed. So eventually it will be not 0.14 millimeter, it will be 0.2 every millimeter. Eventually I need to change the number I take from the operators for X and Y for resize. That need to be in your head before we start to put the size. So eventually, when we make a resample and we change the size to 50%, we need to change the scale X and Y from to half. So eventually it need to multiply by 2. Eventually. Okay. I hope this idea or this point is clear. And we don't change it. The number we take from the operator, we put it in the device or in the software. Okay. Clear. Okay, so eventually, first things we do, we need to put the scale. How we put the scale? We go to image and go properties. It will give me this one. So he give me that Z, it's 160, and he told me the pixel size, which is X, pixel height Y, pixel depth with Z. So eventually, this is Z, X, Y, Z. So eventually, we need to know now this number. It will be, this is the unit. So the unit, I know it's millimeter, put millimeter. So now he give me that the pixel width is 0.18 and the pixel height is 1. If I know the number, I put the number. If I don't know the number, we can do another things, but it's out of, we don't need to do now. So you need to know the number from the operators and we put XY. So it will be very, very good idea that you send me the XY and Z for the scans, the number you take it from the operators, and try to put it in here. Okay, let's try. We assume that the number is right. And we can check, by the way, we can check. After we put X, Y, and Z, Let's assume we have the Z voxel depth is 0.2. For example, if we have we have the pixel width is 0.184. Let's assume that we don't change it because we don't know it. We assume that it's right, and we can check it's right or not. Just a second. 184. Yeah. Okay. So most important things need to be global. What's mean when I check this box global? That's we apply these properties for all 160 slides. So eventually we need to be global. Then click OK. Okay. Let's check first we have the right things or not. How we can check that? I know that the distance, the diameter of this core is 10 centimeters. So eventually I try to measure, take this ruler, and we try to have the diameter. So we have the diameter here, and we click analysis measure. So it gives me 162. So eventually the scale I put is wrong. So I can calculate the scale. How we can do that? It's very easy. So if I don't know the scale from the operators, but I know the dimension, the total dimension of the sample. So when I know the total dimension of the sample, I can recalculate or back calculate the real the scale. How we do that? We go to, I think we go to analysis. Just a second. Okay. Process. Okay. Tool, yeah, tool. Set scale. It should be set scale somewhere because I was working in imaging, but I download now vision. We have a different arrangement for the tools. This is scale, yeah, there it is. So eventually you go to analysis. Just a second. We go to analysis, set scale. He give me the distance in pixel. The distance is 85 pixel. Known distance, I know the distance is 100 millimeter, the length. So eventually give me the pixel is every millimeter is 8.8 pixel. So when each millimeter is 8.8 pixel. So 1 pixel equal what? So 1 divided by 8.856, it gives me 0.112. So eventually now I know from here, I can know the scale. So eventually I can go back, image properties, and put this one is like you see 0.1129. So eventually he can calculate that. So eventually I put it 1.1129 millimeter, 175. Okay. So eventually this is the X and Y. How I can find this one, the Z? If I don't know the Z, the operator didn't give me the Z. I can do that by, I know the full height or depth of the sample, which is 5 centimeters. And I know we have around, here we have around 160 image, or maybe more 160 image, because we delete some of them. But anyway, because if I know the number, I should have the number from the operator. It's more accurate to have the number from the operator. But if I don't have the number from the operator, we can divide like 5 centimeter divided, or 5 centimeter is 50 millimeter, divided by 200 image, the number of image I have. So it gives me 2.25. So how I find 0.25? I estimated, rough estimate. So eventually in the file you sent me, you told me that we have 200 images. And from my experience, I know the sample height is 5 centimeters. So I divide 50 millimeter, that's divided by 200 images. So if the distance between a slice is 0.25, so I put 0.25. So eventually, all we talk about the pixel width, height, and depth, it should be easy because we take this number from the operator. So eventually, you need to have the numbers ready for you. Eventually, you just open, put these numbers in the properties and click OK. So eventually, to be just recheck, if we make analysis measure, it should be give me 100 because I make the scale from it. Okay, that's first things to do. So eventually, now we have put the right scale. So this image now is to scale. So eventually, now we can work with millimeter very easily, no problem. Second, this is the first step. First step, import the images and try to put the right scale, X, Y, and Z. After that, we now need to change and make the type of the image type from 16-bit to 8-bit. So eventually, we need first go image type to 8-bit. Okay. Second, we need to now make a selection. So eventually, we need make sub-selection. We don't need to analyze all the core. So when we need to analyze part of the core, how we can do that? So eventually, it's up to you to choose ROI, which is a region of interest, the region you need to make the analysis. It's up to you, actually. So eventually, you can do a square. You can make a core. I find the square is more easier to do than the core. But to be more accurate, to be honest, in my work in PhD, I do like a sub, like what I do exactly. I make a selection that I need. This selection is a region of interest. So eventually, I will make the analysis inside this box. Eventually, anything outside the box will not be included in the analysis. So eventually, I just analyze the air void at the inside the box. Imagine you have a core and you have put the center of the core in the box and analysis just the center. But I found, like we said, that we can make better to try to make the size as simple, like a smaller core. How we do that? Very easy. First, you need to go to edit and selection, go to selection and specify. So I need to choose the type of selection. So first, we need to make the unit, the width, the height. Here, 456 is in pixel. So I know now I put the scale, so I can work in millimeter. So just make scale unit. So eventually now we work in millimeter. Okay, and we need the box, the selection will be in the center. We put in the center, so eventually we don't need to choose X and Y. And we need the shape is oval. Oval is the circular one. Now we can choose from width or height the diameter of this cycle. So eventually we know that the core of the sample is 100 millimeter. So we need to try to make a core inside our core. The region of interest is better to be not exactly the core, because we don't need work on the edges. When we work in the edges, the distribution of aggregate at air void is not very homogeneous. So eventually, if we take a smaller core than the real core and make the analysis, will be more accurate and better for us. So eventually, I think we have the core is 100 millimeter. So eventually, if we take a circle of 90, we'll be okay. So try put 90 here and 90 here. So eventually, we have now a center 90, so it's 90 millimeter. So eventually, we cut like 1 centimeter from the edge. So eventually, we take now a smaller core, not 10 centimeter in diameter, but 9 centimeter in diameter. And we make analysis according to this small core. I hope this point is it's well understand. Okay, after that, we go and make okay. And we have the selection now. We can go and make image crop. After we image crop, we just make it very smaller. We crop the image. Okay, but till now, after we crop, I need to delete everything now outside the selection area because it's out of my region of interest. So I don't need it. So virtually, when I need to make the analysis, I need everything inside our circle, our region of interest. So eventually, how we do that? Simply we go image, edit, and go to clear outside. So edit clear outside. He give me a message. Do you want to do this for all 160 images? Yes. So eventually now we crop everything outside our circle and change it to color to white. So eventually everything cropped. Now we have a smaller core, and this core is now a smaller core with 9 centimeter or 90 millimeter in diameter. Okay. Now we need to make a threshold. Now we go to the threshold. How we do threshold? Now to do the analysis, if we got this image, now if we find here, when we collect anything with the image, we find this is an 8-bit image. What we mean with 8-bit image? That we have a gray level from 0 to 255. 0 it's fully black, 255 is fully white, and anything between is the gray level. We have gray color. So eventually we need to change the image to just 2 colors, black and white. We don't need anything between. So eventually if we put here, we find the value here. If we find the value, it will appear here. It should give me a 0. If it's fully black, it should give me a 0. But because it is not fully black, it will not give me a 0. It give me a closed 0. And here, so it's not white, it's gray. It give me 150. So eventually, we need to do something called a threshold. But I prefer before doing some threshold, because this image is do it by X-ray. So eventually, we expect almost we have a noise. So eventually, we need to do some analysis or some filter. We need to filter this image to try to reduce the noise as much as we can. So eventually, not everything is perfect, and we need to deal with it. So eventually, it depends on how quality and the energy source, the setup for machine and properties of the machine and operation thing. So eventually, we try to deal with what we have, and we can make the thresholding. How we can threshold? Before we make thresholding, we need to try first to reduce noise, and can reduce noise by doing some filtering. We filter the images, and I found that filter is a big thing. So eventually, we have a lot of options to filter. Multiple filter we can apply to have different effect and reduce the noise. So eventually, during my PhD work, I found that I use 2 filters. It does the job. Eventually, it does the job. So eventually, what I do 2 types of filter: Gaussian flare and median filter. So how I do the filter? Go to process, filter, and choose a Gaussian flare. See, he will ask me the radius. So eventually, don't click in millimeter. So eventually, if you click in millimeter, that will be reduce the scale. So eventually, I found that if I make a sigma is 1 and make preview and click OK, so he will give me a message that I will apply the filter for the 160 image. I said yes. And after that, I make another filter process filter is called median, and I choose 1 or 2 pixels. Let's try 2 pixels. 2 pixels. Good. Preview. Not bad. Okay. Yes. So eventually, you need to be clarify with your filters. I found it's good to have just 2 filters, Gaussian blur and median, with 1 radius for Gaussian blur and 2 pixels for median. Eventually, if you find, after that, we can now start to make the threshold. How to do the threshold? So eventually, we go process. Just a second. Okay, image adjust threshold. Now we do adjust threshold. You found that now he marked anything in black and give it a red. So eventually he choose the air void because we know that the air void is the black. So eventually, if we say this is aggregate, if we assume that's not 0, so eventually this is aggregate. The black is air void, and this thing is like a little bit darker, not black, not white, or not white gray. This one is dark. This one and this one, this lines. It's a bitumen. So eventually, it's the bitumen. So eventually, we need to select just the black. How to select the black? Like we said, we go to. We need to make the threshold. We go adjust threshold. Okay, default. Okay, just a second. Adjust threshold. Okay. So eventually, if we find I think he makes the threshold is 99. What means 99? That anything is from 0 to 99, consider it as black. From 99 to 255, consider it as everything else, which is aggregate that plus bitumen. Okay. So eventually, he have like integrated algorithm and plug in inside imaging. He can calculate the threshold for each. He have a built-in algorithm that can built-in algorithm that can find the threshold for each image. So eventually, I found that is a good. I click apply. He will ask me, do you want to calculate for each image? I make it click yes. And this is just how the color, the background will be. It will be black. What the type of background? Let's make it dark. It's fine, dark. Okay. And click OK. So this we have calculate threshold and make black background and click OK. So mention what he do. Like we see now, we have the black which is the air voids. Now we have which is the number is 0. If we see the value here, it's 0. Anything else is white, 255. So eventually now we select the background, and we can use this scroll to go from slice number 1 to slice 160. Okay, now we need to do something else. Now we finish this. Okay, after that we go to process, binary, make binary, click OK. Now we need to tell the imaging that I need to find the properties of the black. So eventually the imaging understand that do you want to make the analysis for the color of black or the color of white? So we need the properties for air void, which now it's a black. We need to use some logic now. Sometimes we need to use a present because it can't be done the other way. That everything is black, the background is black, and the air void is white. Okay, so eventually if we found that the value of the black is 0. Okay, how we can find that? How we can how we can know that we make the analysis for the air void, which is the black. To make sure we can go analysis particle. So that's for just for trial, and click OK, and check display result, check clear result, check summarize, and click OK. Do you want to do for all 160 images? Yes. He will give me now, after finishing, he give me 2 result window. I am more interested in this one, the summary of the samples. So I will close this result. Don't save, I don't need it. So eventually now he worked this window. He gave me for each slice, he gave me 3 things: the count, number of particles, the total area in millimeter, the average size, the percent of the area from the total. So eventually we have, it should be 160 image. Okay. So eventually now he give me the percent. How much? Is 74%. So eventually it's very logic that he now calculate for the white, not the black, because he give me inside this interest, region of interest, he give me that he calculate the area is 74. The majority of the area is white, not black. So eventually now he calculate for the majority. So I have 2 options. Either by, because I know, for example, in this slice number 1, he tells me that there is 73 counted. 1, 2, 3, 4, 5, 6, 7, 8. There is 73 parameters. Okay, and the total area is 4,780 millimeters square, and the average size is 65 millimeters square. So eventually I have 2 options. Either I have 100 minus 74, and he will give me the right percent for the black for the air void, or I can invert the invert and make the how invert it, because from my experience I found always he calculate for number 255, because this one is 0. If we go to the 0, for if we look for the value, we found it is the air void is 0. So we need to change it to the air void to be 255. How we can do that? Simply we can go to process, make binary, convert to mask, and make light. And this not, we don't need it anymore now because we already calculated the threshold. And this go again. Okay, so eventually now we have, okay, now we have white color with the value of 255. So eventually if we go now, okay, something else we need to be sure that we don't have the selection. We lose the selection now. We need to restore the selection by make edit selection, restore selection. We have the circle again because we need everything inside the circle. It's not very important because we just calculate the analysis for the white. But anyway, so eventually we go analysis, and again analysis particle, we click OK and yes. So eventually now we have the right things. So eventually now this is not important. Now we have that the area is 25%, which is very logic, and the total is dropped to 1,597, which is very logic. So eventually now it's very logic. Okay. After that, I prefer to do something else. What can we do? You see this small point, small white point, very small white point, this one. And this one, very small white point, this one. This point this point is I think it's noise and it's not air void. So I prefer to remove them. Before I make my analysis, I prefer to remove them. How I remove them? Very easy. I go to analysis. When I make the analysis particle, I told him make analysis particle. That's from my experience, this number. That's anything less than 0.5 millimeter square, any area less than 0.5 millimeter, delete it. I don't want it to be included in the analysis. So eventually, I need to generate new images. How to do that? I show mask. So eventually, I need to generate a new image without the smallest white things. So click OK. Yes. So eventually, we have now the file, what we needed, this file. Okay. So eventually now, and we have a new called mask of the sample test. So eventually we have a new file, and if we compare the two files, small, let's take the first image and first image. For example, do you see this white small, small point? And we can find it in the mask because if the area is less than 0.5, it deleted. So eventually now this more cleaner. This the mask image, the new image is cleaner, and we remove all the small points, which I think it's maybe it's air void or not air void, but it's from experience I find it's good to remove it. Maybe you can reduce it or not. Right. Okay, now we need to delete this one because we don't need to work with this, and we need to work with the mask, the new images. Now we found that we don't have the selection. We need to restore the selection, restore selection, and we have the selection. So eventually, now if we do our things, before I found it very good that you save this image, this sequence. How to save it? File, save as, image sequence, and let's name it okay. Choose the file. So eventually I try to find and call it mask sample test. Open, save. So eventually now we save because now we can store them and we do the analysis, and we don't need to do all the steps we do now. Okay, now I have the sample, its threshold and ready for measurement, and this is ready for measurement. So for this video, I will not stop from here. I will stop here and I complete a new video. So eventually, this is the first step that I have the image, convert it to 8-bit, insert the probabilities, pixel width to height and depth, make the selection, crop, make the filters, make the threshold, and after make the threshold, remove all small particles, and save the images, the threshold images. This is the first part of before we start the analysis. I will end this video because I want to make the video smaller because it's easier to upload them. And we will complete in video number 2 from this point and start the analysis process. Yeah. Okay. Thank you and see you in the next video.